Section at 5.3, you move on to second type, right? Just like greatest common factor was the reverse of multiplication, factoring trinomials is going to be the reverse of multiplication. Trinomial factoring, factoring trinomials. Greatest common factor was taking a single term and timesing it by, it's the reverse of timesing it by something like that, right? It's doing the reverse. It's factoring out the greatest common factor. Trinomials is going to come from just working with the pattern that you notice in factoring, the pattern you notice in multiplying two binomials. If you take any binomial here, like x plus 3 and x plus 4, and look at what the product is when you multiply it out. When you're using an area model, okay, remember we did an area model and you had 4 pieces to the area model, sort of. That doesn't look much like a rectangle, this one, but we can try again. Close enough, right? There we go. If you do x plus 4 and x plus 3, look at the pattern you get and what happens with the terms, right? How many terms do you get when you multiply out two binomials? You get 4. 1, 2, 3, 4, right? It doesn't matter how you draw the lines. You might want to draw the lines like this. 1, 2, 3, 4. Doesn't matter, right? As long as you connect each of the terms here with each of the terms there. Or visually, what you're doing is you're connecting, or you're multiplying each part of this times each part of that, just like you did when you're multiplying numbers in grade 3 or 4. You're hopefully getting better at realizing, quickly what the terms are. X times x is x squared. X times 4 over here is plus 4x. And over here, x times plus 3 is plus 3x. And then you got plus 12 here. There's 4 terms here. But when you write the final simplified answer, think about what you have. So you got x squared plus 4x plus 3x plus 12. When you simplify it, what do you end up with? You don't end up with 4 terms, you end up with 3. X squared plus 7x plus 12. If the two brackets have the same variable in them, x, and a number, you end up with 3 terms. Okay? 3 terms. So what we're doing with factoring trinomials, the second kind of factoring, is just going to work backwards through that pattern. You have to notice where things come from. The first term comes from one place here. Where does it come from? In the rectangle, it's this piece right here. Where does it come from? It comes from... What terms in the two brackets give you that x squared? Where does that come from? It comes from the first thing in each brackets, right? This comes from the first thing in each brackets. Where does this last number come from in there? It's this rectangle here. Where does it come from from this? It comes from the last two things, right? Those last two things. There's that. But where does this middle term come from? This comes from the first term. This comes from the last term. Where does the middle term come from? 2 places, right? It's these 2 things together here, right? This and this combined together. Okay, combined together. It comes from what you might want to call, some people call this the outside terms. So let's join this one up over here. It comes from the outside terms and the inside terms. Okay? This comes from 2 places, outside and inside terms. Some people actually use this word here, FOIL, to remember that pattern of where things come from. And you're just going to be working backwards through that to try and factor trinomials. Okay? In this section, it asks you to multiply out a bunch of trinomials, like 2x plus 3 and x minus 1. If you're trying to factor things, at first you have to know how to get the final answer from this. It would help if you can get the final answer without a lot of steps in between. The final answer here is going to have 3 terms. It's going to be something, something, something. Where's the first one going to come from? in our pattern here. If we multiplied it out, it's going to come from those first two terms, right? What's the first term going to be in our final answer? It's going to be 2x times x, right? 2x squared. I would look next at the last term. Don't look at the middle term because the middle term comes from two places. Do that one last. Where's the last term come from here in our final answer? It comes from the last two terms multiplied. So what's the last term going to be? You got plus 3 times minus 1. So it's going to be minus 3. Let me erase all the red lines over here. We have the first term and the last term. The middle term comes from two places. Where does it come from? It comes from this times that. And it comes from this times that. What are those two terms going to be? Think about what those two terms are. What are the outside terms going to give you? 2x times minus 1, what does that give you? It gives you a negative 2x. What do the inside terms give you? Plus 3 times x gives you 3x, plus 3x, right? Plus 3x, half my x disappeared up here. What does that combine to in my final answer? What am I going to have as the middle term? I'm going to have plus x. That's the result of this. When you're factoring, there's a lot of different approaches you can take to factoring. Factoring is going the other way. If someone gives you this, you have to give them back 2x plus 3 times x minus 1. That's what you have to give them. You're going backwards, right? You're giving them the multiplication question that has that as the answer. Okay, so it's and you already did this with Algebra Tiles. And you had to add in 0 pairs and stuff. Adding in 0 pairs was because when it's simplified here, how would you represent that with Algebra Tiles, that plus x? How do you represent plus x with Algebra Tiles? You got one single green tile, right? But in the original question, we had minus 2x and plus 3x. So we would have 3 green tiles, 2 white tiles, right? You need to add in some. When you're going this way, you take negative 2x and plus 3x, you combine it together and simplify. Get rid of some green tiles and white tiles, 0 pairs. When you're going backwards, the other way, you're going to have to add in some 0 pairs if you're using Algebra Tiles. Or in doing it this way, you're going to have to think about what the two terms might be. So let's try an example here. In the textbook, they tell you to look at the product of the first and last term, and then look at the middle term or something or other like that. I would just use a kind of a logical approach to this. And if somebody wants you to factor something like x squared minus 10x minus 24, let's make it plus 24 first. And then let's factor x squared minus 10x minus 24. Because it's going to be different. It's harder when the last term's negative, but let's try factoring those two things here. If you're trying to factor that, again, don't lose sight of the goal. If you have something that's x squared, something x, something without an x, if you have those three in a row, the terms like that, so it's that kind of form. It's a trinomial that goes x squared, x, and just a constant. You can try factoring it into 2 binomials. That's what we're trying to do. I think the best approach is just using your logic and a bit of kind of guess and check, because you're going to get pretty good at it if you understand what you're doing. Look at the first term and look at the last term, but then ignore the middle term for now. If the first term is x squared, how many possibilities do I have for what could be at the beginning of each bracket? What could be at the beginning of each bracket? If it's x squared, okay, if you think about the rectangle, what does it got to be? Think about this rectangle up here. If you have x squared, there's only one way you can put these two things. What can it be? X and x, right? X and x. If you want, you can actually draw the rectangle, right? We can draw the rectangle here if it helps, because it might help as we go here. Let's draw the rectangle. make our 4 pieces. You don't have to, but you can if it's a strategy that works for you. If you have x squared, you know x squared's got to be from the first two things, right? And the 24 has to be from the last two things, right? You know those two. This is the first, this is from the last. It's got to be those two. The hard part is figuring out how to pick these two numbers so that it works for both, right? How to pick the two numbers that are there. If the first thing's x squared, it's got to be x and x. We already know the first thing has to be x and x. If you know that the middle term is minus 10x, we have to split up the minus 10x somehow between this spot and this spot so that it's going to work out to plus 24. If this is plus 24, you can't just put random numbers here. You can't say I got minus 10x, so I'm going to put minus 7 and minus 3, right? Sorry, not like that. You can't just do it so you say minus 7x minus 3x. That's not going to work, right? Because what would that mean this has to be? This would have to be a minus 7, and this would have to be minus 3. Does that work? It doesn't work for this number down here, right? You have to pick numbers. You have to split it up so it's going to work for that last number, right? What are my options for what I can choose there? What are my options? If that's a 24, and it's positive, but this has to be negative, what does that tell me about these two things? They both have to be negative. Both of those have to be negative. What possibilities do I have here? I'm going to list them up here. It could be 6 and 4, and it's minus 6 and minus 4, right? Because it's got to be negative. It could be minus 3 and minus 8, couldn't it? Because that would give me my positive 24, wouldn't it? It could be minus 2 and minus 12, couldn't it? It's not, because it's not going to work with. Whoops. But at least that's a possibility, isn't it? Oh, come on. Let's just move this. Sorry. Making a mess of this thing. Oh no, what's happened there? Okay, we'll fix this. That's gone. There's lots of things it could be, right? It could be minus 6, minus 4, minus 3, minus 8, minus 2, minus 12. Or it could actually be, couldn't it be minus 1, minus 24? Like I could put minus 1, minus 24 here. That would give me the right number here. But would that give me the right two things here? No, right? Which one does it have to be so that you get the right middle term? Has to be 6 and 4. Has to be. Okay? Get rid of the space here now. Has to be 6 and 4. It has to be minus 6 and minus 4, right? If this is minus 6 and this is minus 4, it gives me the right thing. Minus 4x minus 6x. That's going to combine to the right middle term, and then that's the right last term. If it helps to do it as a rectangle, please do. If it helps to just think through the possibilities and make a list and not use the rectangle, if it helps to just kind of list the possibilities and then figure out which one works, that's fine too. Okay? It's got to be minus 6 and minus 4. It doesn't matter the order. Those two things multiply out. How could you check if this is right? How could you check? Multiply it out, right? It's something you have to know how to do. You say x times x is x squared. Negative 6 times negative 4 is the right last term. And then the middle term comes again from that times that. And that times, sorry, not that times that. And the inside ones, outside and inside, those two. What about if this was minus 24 in the end? What's it going to do to the numbers I'm going to try here? I'm going to adopt the same thing here. I'm going to say, if this is x squared, it's got to be x and x for the same reason as before, right? It's got to be x and x. Okay? If you like the rectangle, draw the rectangle, if it helps. You could actually use algebra tiles to factor too if you want. If that's x squared, there's got to be x and x there. If the last number is negative 24, what does it tell you about these two numbers? What has to be true about those two numbers if the last number is negative? What has to be true about it? Yeah, one has to be positive, one has to be negative. The fact that that's negative means you got one positive, one negative. I would, in your brackets here in your answer, I'd put that right away. I'd put plus and minus. You know it has to be a plus and a minus. Okay? The fact that this is minus 24, you know it has to be plus and minus. So I would put plus and minus here, and then you can figure out what the numbers are going to be. I would just make a list of numbers that multiply to this last number then. Okay? The last two numbers here, these two numbers, have to multiply to 24. Make a list of what they are, and then check that it's going to work. What numbers could it be? 24, we got the list over there. 6 and 4, 3 and 8, 2 and 12, 1 and 24. But since there's a plus and a minus, we got more things to check here. We got more things to check because we also have to check the other way around. This is checking plus 6 and minus 4, plus 3 and minus 8, plus 2 and minus 12, plus 1 and minus 24. If it's a negative, if one of these is plus and one of these is minus, right? That's going to be plus, that has to be minus. We're not looking for those two numbers to, we know we're going to have to combine them, like some of them are going to cancel out. If the last number is negative, you're going to have some zero pairs that cancel out. I can't put plus 6 and minus 4 because is that going to add up to negative 10x? It's not, right? I got to put it in so that they balance out to negative 10x. Which one of those is going to balance out to negative 10x? Even just ignore this. It's not that they're going to add to that number. Like over here, the 6 and the 4 added to 10. We got to look for the difference here. Which one has a difference of 10? Which one's going to work? 2 and 12. I can put the 2 and the 12 in, so it's going to work. If I need this middle term to be negative 10x, which way do I have to put those numbers in there? If I need it to be negative 10x, can I put the 2 over here and the 12 there? No, it's got to be the other way around, right? It's got to be negative 12x here plus 2x there. Or in other words, that's got to be a 2. That's got to be a minus 12. You should in the end here write the answer properly. It's x minus 12, x plus 2. You don't have to draw the rectangle unless it helps you. You're going to hopefully get pretty good at once you multiply things out and look for patterns and stuff. You're going to be able to do this. Just realize that when the last term's negative, there's more things to try because you can try one positive, one negative. Last thing that becomes difficult is when the first number is not 1. This is what you had trouble with the algebra tiles, I think. For example, if you have to factor something like 2x squared minus 3x, let's do plus 3x minus 5. Okay, if you're going to try and factor that. Let's think about how you might factor that. There's a lot of different approaches, right? There's the just trial and error. It's not just trial and error, it's educated trial and error. Or there's drawing the rectangle and thinking about how it has to be, which are kind of the same thing, but if you're a visual person, maybe the rectangle's better. Where's the first term go here? First term, the x squared terms, where do we put it? Which one of the 4 boxes? Top left, right? There's the 2x squared. What goes in this box down here? That's the minus 5, right? We're going to ignore the middle term at first. We'll try and figure that out after. Why is it harder when the first term's not just x squared? Why is it harder? What do you mean? We're trying to come up with this. Why is it harder? You got to listen, okay? Is it just x and x if that's 2x squared? No. What does one of them have to be? One of them has to be 2x. That's the only way. 2x and x. If you're doing it just by drawing this, put the 2x in there first. And the x. Fill that in. That's going to create more possibilities. This one has a lot of possibilities. even though if the last number is 5, what are the only numbers I could use to get 5? It's got to be 1 and 5. You know when you were factoring with the algebra tiles, that was like how do you arrange the unit tiles, the little red ones or the white ones? How do you arrange those? If there's 5, the only way to arrange them is a line of 5. 5 times 1. It's got to be 5 times 1, right? This gives you 5 times 1, but there's a lot of different ways you have to try it. Because you got to try negative 5 times positive 1, or positive 5 times negative 1, plus there's 2 different ways to try it here, right? Since these are different, you have to try all 4 of the ways in each spot. You have to try negative 5 and positive 1 over here, or you have to try positive 5 and negative 1 over here, or the other way around, negative 1 and plus 5, or plus 1 and negative 5. Those are all the things you have to try. If you're doing it this way by just writing the brackets, you can just write those 4 things. Plus 5, negative 1, negative 5, plus 1, plus 1, negative 5, negative 1, plus 5. There's 4 things to try even though there's only 1 pair of numbers. There's only 1 pair of numbers that gives you 5, but there's 4 things because number 1, you have plus minus. And number 2, since these are different, you got to try it both ways. This seems like a lot of work just to get the 2 factors here, but you're going to get quicker at it when you recognize patterns. This is not something to do by memorizing 20 different kinds of examples. It's something that the more you try of them, the more you'll recognize patterns and say, I know it can't be that, I know it can't be that, it's got to be this. Like you might say they're opposites here. I'm aiming for 3 plus 3. I know that if I put it in here, I'm looking to get the 3 from the outside and the inside terms. You might be able to tell right away that if you put the 5 here and the 1 here, no matter how you put the signs, what are the 2 terms you're going to get? You're going to get, the outside's going to give you, if you put the 5 there and the 1 there, the outside's going to give you 10x, and the inside's going to give you 1x. Does it matter how you put the plus and the minus in there? Is there any way to make that combine to 3? Even if this one's negative, or if this one's negative, doesn't matter. There's no way to make that combine to 3, is there? So if you can see that right away, that gives you 10 and that gives you 1, you know it can't be either of these right off the bat. Because 10 and 1, there's no way to subtract them to 3. So you know it's got to be the other one. If it factors. So you know that the 5 has to be here and the 1 has to be there. And then you can just think, well, I need it to be plus 3. That gives me 2x. I'm not going to put the signs in yet. That gives me 5x. Which way do I have to have this to get my 3, plus 3? Which way do the signs have to be to get plus 3? It has to be negative 2x and positive 5x. So what does that mean? Which one's the negative one? It means the 1's got to be negative to get negative 2x, and the 5's got to be positive. You're going to get good at narrowing down the possibilities pretty quickly as you do more of these. This is not something you can get by just doing 1 or 2. You got to do lots of them. Okay, we're going to practice this a lot. I would like you to spend time right now, even if you still feel like you're not finished a previous section, work on this right now. It's better to work on the current thing now, then go back some other time and finish old stuff. Okay? The analogy is, I think I've told a few of you this, if you go to the store and buy a bag of apples, then you put it in your fridge, but then it gets kind of old, but you forget and you buy a bag of new apples. But you say, I better eat the old apples first before I eat the new apples. You eat the old apples. What happens to the new apples while you're eating the old apples? They get old, right? So you eat up all the old apples to get to the new apples, but by that time, what happened to the old apples? The new apples, they're old, right? You don't want to always be eating old apples, right? You got to work on this when it's fresh in your mind and new, because otherwise it's not going to be so good and not so easy, right? Work on this now, then go back to the other stuff. Section 5.3, work on that right now, okay?